These ones have to do with the same idea of identifying what's happening at that long-run behavior of your graphs. But this time, instead of giving it to you as the actual graph, it's going to give it to you in terms of a function. And the function isn't going to be written as a polynomial. It's going to be written in its intercepts, or as in its factored form. And so what you're going to have to do is you're going to have to count up the powers of x. You don't have to physically expand this. And so I'm not asking you to type this into your calculator and expand the expression to get a polynomial here. All you need to do is know what is the total power of x. Okay? So when you look at these individual factors here, you have 8 or x to the 8th, x to the first, x to the first. So how many total powers of x do you have? The degree is going to equal what? 8 plus 1 plus another 1 gives you 10. Okay? So when you look at this, you now know your graph is going to be that of an even power. So it's going to be one of these two. And when you look in front, is this leading coefficient a positive or negative? Here it's a negative. So is our graph going to open up or down? It's going to open down, right? So we know it's this one. And so, again, we don't know what's going to happen in the middle, but we do know the end behavior is going to point down. So as x approaches negative infinity, so as we move to the left, what's happening to our y's? Our f of x, our outputs, our y's are getting lower, so they're going to approach what value? They're going to approach negative infinity, right? They get lower and lower. And as x approaches positive infinity, okay, as we move to the right on this graph, what's happening to our y's? It's getting lower and lower again. So that's also going to approach negative infinity. Okay, I want you to try that same idea with this second example. See if you can identify what's happening to the end behavior using that arrow notation of is it approaching infinity, negative infinity, or 0? And it will be your options from the drop-down. All right, so what's the total degree when you look at all these factors? You have 4 for the power of x, plus 1, 2, and 3 more. It gives you a total degree of 7. So the highest power of our polynomial, or the power of our polynomial, is going to be a 7. So we're dealing with an odd degree. So it's either going to go up and to the right or down and to the right. And when we look at the leading coefficient, a negative 9, it's a negative. So we see it's going to fit this pattern here. So as x approaches negative infinity, what happens to that's the left behavior. Our y's are going to go up. They approach infinity. And then as x approaches positive infinity here along this graph, it's going to go down. Again, we're looking at this as our basic form. So it's going to go down as we move to the right. And so that's going to approach negative infinity.